This is AP Calculus AB. We are on Unit 11, Lesson 1. This is our last unit of all of calculus. And from here on out, after we finish the unit and the test and everything, we go into peer review for over a month. All right, so where are we in this unit? We are on 11-1. There are only 5 lessons this unit, 2 talking about area, and then we have 3 talking about volume. And volume is a tricky topic, so it'll be fun when we get there. All right, so here's the setup. We are on standard W. W is finding area between 2 curves, is that? Or just area? So I just want us to graph sine between 0 and 4. And I'm going to label the area R for, I guess technically R is down here as well. But both of these are R. I need to find what's happening in R. And, oh, so actually I need to follow the instructions, which I didn't do. I need to make sure that my region is bounded in the first quadrant. So if you forget your quadrants, you can do a little sketch off here to the left-hand side. It goes 1, 2, 3, 4. Usually these are Roman numerals, although I'm just going to use the, what is this? The Hindu, I don't know. I'm just using the normal numbers instead of using Roman numerals. So I'm not talking about R down here. That is in the 4th quadrant. I'm only talking about R up here in the 1st quadrant. All right, so how do I find the area here? Everything in this unit has to do with calculators. So make sure you have your calculator out and ready to go.
Oh, can I borrow one?
You need to borrow one? Perfect. There you are. All right, so we need to calculate this region here. So how do we do that? Well, we need to have our bounds for our integration. So we need this point. I should go back to using blue. We need to find that point. Where is it? And this is something that you should be able to do without a calculator. All right, so girls,
3.
It's not at 3. Where is sine of x? Where is that equal to 0 for the y coordinate?
CV is 0.
What is the x coordinate here?
It's like 3. Only 1. Wait, no. Wait, 0.
No. What is this coordinate? It's 3. It's a little bit more than 3. A little less than.
3.1.
It's sine. So does that give you any hints?
Sine of 3 pi, just 3 pi over 2. I don't know.
I was going to say 2, but I was like, that's 2.
Okay, so we need to review our unit circle also. All right, so here's our unit circle on the side. So we have a circle. So there are 4 points that are really important for sine and cosine. Remember, sine represents the x or the y coordinate.
The y.
Y coordinate, and then cosine would represent the x. So I'm looking for wherever I have a y coordinate, or the height is 0. Look, the height is 0 there and there. So what is the angle that I make between this x-axis and this point? What is that angle
30. 60.
for this point right here?
0.
0. That's one place where sine of sine of 0 is equal to 0. Sine of this angle is also equal to 0. What is this angle? Pi. This angle right here is pi in radians. It's 180 degrees. When you convert it to radians, everything in AP Calculus is in radians. We know that that is also going to be 0. Therefore, what is this x coordinate?
0.
Pi.
Pi. It's pi day.
Oh, 3.1.
Exactly.
We should have gotten that. That's so dumb.
All right,
But
perfect.
why is it, if it's on the, I don't get it.
You don't
Because
get.
you said it's on the left.
This is using your unit circle. Unit circle is different. It's another way of writing your sine function. So unit circle, we're looking for where we have a height of 0 because sine represents height.
So 0 is the y.
Oh, okay.
Both of these degrees, both of these angles, sorry, will give you 0 when I punch in for sine. So sine of 0 is 0, sine of pi is 0.
But we could also do that on our calculator.
You could also do it on your calculator, but you should know that. All right, so I need to somehow say on my calculator, find this area under this curve. So what is my integral going to be, ladies? R is going to be the integral between
0 and 4. 0 to pi.
0 to pi, there it is.
You sounded so disappointed.
We just went through all that work to define where it intersects.
Like savage.
All right, 0 to pi of
F of X.
f of x, exactly. Or we could have put sine of x in there, and then we'll put a dx. Okay, on our calculators, let's do that. So let's clear this. So I'm going to do, I can either do it with a graph or I can do it without a graph. I'm going to do it without a graph. So math 9, I'm going to do the integral of sine of x, and that's going to be from, or with respect to x.
Can I turn off the lights?
Yes, please do. From 0 to pi. And pi is second power. There's pi right there. And you'll find that that is 2.
Wait, you entered your x as pi or?
So
Oh, just kidding. Never mind.
you got it? Okay. So this thing is not approximately equal to, it is exactly equal to. It is exactly equal to 2. And knowing that we have to round to 3 digits, we'll also say this, 2.000. That tells the AP graders I did not round, it is exactly 2. I rounded to 3 decimal places, those are the 3 decimals that come after it. All right, so far so good. We remember how to find area under a curve.
I suppose.
Yep.
All right, let's do the harder part now. Remember, today's title is area under 2 curves. So here are your 2 curves. Your first curve is still sine, and I should say sine of x. And your second curve, in quotes, I'm doing finger air quotes right now. Your second curve is 2 minus x. Remember, curve is just a generalized math way of saying a function, a function graph.
Same graph over again.
You can say, yeah, same graph over again, but now I'm going to do this new graph, g of x is equal to 2 minus x. And I'm still restricted to the first quadrant. Let's still say that.
How many slides are there?
This is the last slide. We're done after this. All right. I want to find the area under these 2 curves. So still restricted to the first quadrant, so don't worry about anything happening over there. What's under both of these curves? So this area here is under sine. This area here is under my g of x, but under both of those, that's going to be the intersection. I'm really looking for this area right here. So how do I find that area? And I'm going to tell you. So whenever we have the integral, we always go from the x-axis to whatever is above it. So directly above the x-axis here is f of x. Directly above the x-axis here is still f of x. Right here, at this really critical point, right above this point, is both f of x and g of x. And what's happening here? This is only g of x. So it seems like our integral starts off with f of x and then ends with g of x. And the way that we write that is there are 2 integrals. So you can keep those lines. I'm going to make my notes a little bit neater. I'm just going to do r just like I had before. Sorry if you want to copy that. So this area here, that's r. So what we're going to need to do is we're going to have to divide this into 2 regions. And I'm going to use a straight line here to say that. I'm going to divide this by drawing a straight line down here. There is one area here. Both of these are area that I'm looking for. I need to add them up though. So how do I find this area? I'm going to label this area, I don't know, A. How do I find the area of this A? What is the integral? By the way, both of these added up is going to be r. So I'm still going to say r is equal to, it's really equal to A plus B, because I'm going to say this is going to be B. So how do I find the area of A? And it's the same thing that we were doing in our last slide, but now I cut it off right here.
You look.
What's the notation?
It's integral
It is going to be using the integral. So integral from where to where?
0 to 1.
Okay, 0 to, and we have to be careful here.
Oh, it's a little further than 1.
We don't know where this is. We don't know what this x coordinate is. It's a little bit further than the 1, so how are we going to find it?
You know, we're gonna click 0. I don't know.
Pythagorean's theorem.
That's a cool idea, but it's not exactly a triangle. So this is what we're going to do. We're going to use our calculators. So pull up your calculator. Let's go ahead and graph both these functions. Remember, one of the graphs should be sine. One of them should be 2 minus x. So I'm going to say my first function is going to be sine of x. My second function will be 2 minus x. My window is going to be, let's just do between 0 and 4. Actually, let's just do 0 to pi because we know that's where it ends. So we'll say from 0 to pi. And then zoom 0. you should hopefully get a graph that looks like this.
It did.
That's how it's supposed to be.
All right. So how do we find this point of intersection between the two graphs? Someone walk me through it.
Just hit second trace.
Second trace, intersect. Intersect is 5, so I could scroll down, or I could just rapidly hit 5. And it's asking for the first curve. This is, the reason we have to choose curves is sometimes you have 3 curves up here. Usually you're only going to have 2. So I say first curve, sure, that's the first one, enter. Second curves, it automatically jumps to the second one for me. I just hit enter. And then take a guess, because sometimes you can have multiple intersections. I'm going to scroll over and hit enter. Alternatively, instead of going left and right with the arrow keys, I could have just hit 1 and hit enter. And it will tell us that the intersection has this x coordinate and this y coordinate. We only care about one of these.
The x coordinate.
The x coordinate. Let's record that.
Did you get 1.106? Oh.
I did, in fact, get 1.106.
Okay, because sometimes it scares me. Like, how do I know I'm not going to get like 1.107?
Yeah, I get scared about that too.
I would say don't be scared. It'll be fine. It will work. All of your calculators are the same.
I shouldn't be scared, but it's just that like when you're like, just take a guess of where it intersects. Like
It
that's what I'm
doesn't
like.
sound
Wait,
reasonable.
Okay, so coming back here, we know where our integral begins. It begins at 0, and this area for A ends at 1.106. So we can say that 1.106. Now here's the tricky part. What function am I using? I'm either using one or the other. I don't use both for this lesson. Next lesson we'll talk about a different story.
What do you mean, function?
What function am I going between the x-axis and the curve? Which curve am I hitting from the x-axis?
I think
I'm using, sine of x. So I'll say, I can say just f of x to be fast if you want. If you want to say sine of x, that also works. This whole thing right here, that was A. We just found A. So now we need to add this to the other area. So we just did this area right here. Now we need to do this area right here to add them up to find the total area underneath both curves. So my integral is going to be between what and what now?
Do you want to put dx?
Oh, yes, I do. Extra credit right there. Log it in your extra credit tracker.
1.106.
From 1.106
2?
to 2, yeah. And what is the function that I hit from the x-axis going straight up?
G of x.
G of x. Perfect. Let's find this. On our calculators, let's do this. Another extra credit point. Yes, log it. I should be remembering how to do that. And this whole thing that we just found right here is B. If we add up A and B, we find the total area R that we were looking for. Again, we don't care about this area over here because that's not the area under both curves. All right, so let's do that on our calculators. So to do that, you can either use the graph and you can do second trace and do 7. I prefer doing it without a graph. I prefer going math 9, the integral, and I say of my y1 function. So, I have to be careful. What was my y1? My y1 was sine. So it's actually going to be y2, or yeah, so y1 for me, that's the first one. Sorry. Just making sure I got this right. var is right, enter, enter. So this is my y1, that represents sine. That's my f of x. That's going to be with respect to x from 0 to 1.106. Okay, perfect. I could hit enter, but the fastest way is to just right here say plus this integral.
Dang, it's plus.
Math 9 of var's right, enter 2, my y2 function, with respect to x from 1.106, comma, to 2.
Oh, I've been putting 1.06 this whole time. Oh.
All right, if I hit enter, we should all get the same thing.
0.951.
So we are approximating here. This is going to be 0.951. So to close the notes, these were the steps that we took, and I might write this down explicitly. To find the area under two curves, first find the area that is actually under two curves in the quadrant that you're looking for. Usually AP tests will say only look at the fourth quadrant, only look at the second quadrant. Most of the time, first quadrant. So limited to the first quadrant, what is under both curves? You find the area that you're looking for. Then from there, you need to separate it into different segments, probably going to be 2. To find where the segments begin and end, you need to find that x-coordinate for the intersection points. To do that, we graphed it on our calculators. And then once you have your intersection point, break up your integrals from the correct intervals from 0 to 1.06, 1.106 to 2, and then make sure you know which function you're plugging in. It's whatever is above the x-axis for that section. Whatever is above the x-axis. Above this one was our blue, our f of x. Above this one was our red, our g of x. Take the integrals, solve, calculate. Questions?
Nope.
That's it. That ends the notes. All right, let's take the time to look at number 1 together. So this is from the homework. We're looking to find the area of S. This is the area under both of these curves. We have one curve and the other. So we know that cosine of x is this curvy one, and then y equals x. Obviously, that's our straight line, our linear function. So to find the area of S, we know what area we're looking for. We got step 1 done. Now we need to divide this into 2 parts. So if I divide that, I have these 2 shapes. I need to find what x-coordinate this is. So let's go ahead and do that. I'll give you time to do that right now. Find this x-coordinate using your calculator. All right, so I pull up my calculator and I graph x and cosine of x. The reason why I do this, I'm going to restate this even though I did it off camera, is that I'm going to have this area first. So this area intersects which function first? This x. That's why I choose this one to be x1. And this is my cosine of x. The question that we are all getting hung up on is what happens right here? Where does this intersect the x-axis? A lot of the girls were choosing pi and 3, which will work, but that's not where this intersects. So we need to figure out where is cosine? Cosine of what gives you 0, the height of 0. And Joy correctly told us that in order to get 0, this is going to be pi divided by 2. And to give you the rationale for this, if I have my unit circle, right here, cosine is the x-coordinate. So my x-coordinate is 0 here and here. What angle is made right there? 90 degrees. Therefore, that converts to what for this angle in radians? Pi over 2. Where else is cosine equal to 0?
3 pi over 4. Something like that.
3 pi
Over 2.
over 2. Those are the 2 places where cosine is equal to
Now
0.
we're in the first quadrant.
And we know we're in the first
So
quadrant.
that's how you do it.
So we're pi over 2, exactly.
Okay.
So my window, I can say 0 to pi over 2 to make it really nice. So I'm going to say pi over 2. But if you do 3, that'll still work. It just means you have a lot of wasted space.
Oh, so I was.
You're fine, but you just have wasted space. This is important because you need this for your integrals, though. Look, we have the same function that they gave us in the graph. Looks good. And our graph ends right where it intersects the x-axis. Exactly what we want. All right, we need to say what this x-coordinate is. So, how do I find the x-coordinate, girls? Someone tell me.
Math. Second, trace, 5. And then you hit enter. And then hit enter. And then hit.
Enter again.
No,
It'll work. So, our x-coordinate is 0.739. Okay, now what do? We have the x-coordinate. What do I write down here for my work now?
So, integral
So s is going to be equal to the integral
of 0
from 0 to
0.739.
of what function?
The
Y equals X.
Y equals x. I'm just going to put an x here. X dx. And then I'm going to add that to which integral someone knew? Integral
739
to
to pi over 2.
pi over 2. And then what function do I put here?
Just
Cosine.
Cosine of x dx. Perfect. Then, well, this is going to be approximated, so I'll do our little squiggly equals sign. This is going to be approximately, and then we need to calculate it. So you can either do it with your graph, but I do prefer doing it this way, kind of similar to what we did last time. So it's going to be math 9, far is right, enter, enter. And I need to make this point again because it is important. The reason why I chose y1 to be x, it was because I knew that was the first section I was going to be adding. If I chose cosine x to be y1, then I would have to do this one first for my y1, or alternatively, right now I could be doing y2 for the first integral that I'm doing. Just to make sure that they match up, always choose the first function to be whatever the leftmost area is intersecting. So y1 with respect to x from 0 to 0.739. And that is going to be added to the integral, so math 9 of vars right, enter 2, y2 with respect to x from 0.739 to pi over 2, second pi divided by 2. All right, all of us should be getting the same answer. So if I round to 3 decimal places, this is going to be 0.600. That is the area that we're looking for. Perfect. Are there questions on this? All right. All the other questions are relatively similar to this. Some of them might be a little bit trickier for what function is above the x-axis rather. All right. So good luck. Do you want to say goodbye?